Hi there, this is David from DTU, the Technical University of Denmark. Welcome to this session. In this session, we are going to be talking about numbers and how to describe and summarize different types of data. So we will be describing, summarizing numeric data, but also what is called binary or dichotomous data or discrete data or ordinal data. This lecture belongs to the module Data Management for Epidemiological Analysis. Summarizing and describing our data is very important because it can help us to solve problems or answer questions. Imagine we are in a sewage station, and in this sewage station is going to yield a number of information, and we need to use this information, this data, to solve some questions. For instance, question 1, how many bacteria do we have? So we have to make some summaries to count the data, the information, and count the bacteria. What is the ratio of harmful and non-harmful bacteria? So we have to make some comparisons and summarize our data so we get an average number of resistant genes, for instance. And we can also talk about proportions, how many different type of bacteria we have in this sewage plant. Well, this is just an example, and it's just a way to illustrate the importance of how we can important is to summarize our data. So the learning objectives of this lecture are that you should be able to summarize different data types. By having this ability, you should be able to demonstrate, for instance, how to describe infrequencies, diseases by making graphs or tables. And you should be able to contrast the different data types we are dealing very often in microbiology, in tackling antimicrobial resistance, antimicrobial use, or an epidemiological setting. So what is the plan? The plan is that we are going to look at the different data types we have, which are the characteristics of these different data types, and we're going to see how can we summarize or describe our data so we can learn from this data and give them to this data some voice, for instance. So let me start with what is called numeric data. And we have the numeric data that can be considered as a continuous data. This continuous data is, for instance, time, temperature, weight. And this kind of continuous data, the characteristic is that it can have a great precision. We can talk about hours, but we can also talk about minutes, milliseconds of, from very precise point. Of course, we often rounded this data, but it can be very precise. So this is a kind of continuous data. The second type of continuous data, numeric data we have, is the count data. So the counting here is restricted to integers. Let's say we can count health facilities, number of health staff, number of bacteria, number of chickens, number of farms, round integers. So this is the two different kind of numeric variables we are dealing very often. So how we deal with data of this kind? Well, to summarize numbers, we used spread measurements or average measurements. We also use different type of charts and tables, and this is what we are going to see now. Say we receive the following information, the following data. This is about this diffusion of Staphylococcus aureus, metacycline-resistant Staphylococcus aureus, and we got the antibiotic that has been tested, cefotaxime here, and the millimeters of the test. And we got just over 1,300 observations. The variable m, which is refers to millimeters, is a continuous variable. And the way to summarize a continuous variable with a graph can be with a box plot. So this is a box plot to summarize this information about this diffusion. A box and whisper plot will give us information about some summary statistics. For instance, we can have the median, the interquartiles, the first quartile, the third quartile, and the range of the data. So we can see that the cefotaxime, for instance, the maximum value we get is 28, which might be considered as an outlier. A second graph, very often used for summarizing continuous data, is called the histogram. A histogram is an approximation of the distribution of our data. The data is often saved in these bars where they are called bins. And the data is grouped in bins and then is counted by bins. For example, the second bin contains only 13 observations and it has only observations until 7 millimeters. So these two types of graphs or plots are very important when describing numeric data, the box plot and the histograms. Both of them provide very valuable information to help us to understand our data. Obtaining the average and the spread of our data is very common using numeric data. And the way to do it is to obtain the mean, the standard deviation, and knowing the range of our data, for instance, the maximum and minimum, and the quartiles, the first quartile, the third quartile, and the median. This information is complementary to, for instance, to the box plot. The box plot gives us this information but in a graphical way. For instance, cefotaxime is giving us this information which can be found on the first row here. I have another example of count variables. These count variables can be assessed to a trend when they are matched to a timeline. For instance, we can make a plot with this, which is called a trend plot, and we can see the observations, how they move through the time. In this case, these are SVL isolates detected in the lab through a particular year. So in this particular graph, we can see that we have more cases during the summertime, during the months of June and July. And so we might have to think about why is that the reason we are getting this kind of information. Is it because there are more cases or the temperature? So we can start to make hypotheses. Okay, let's move to categorical data. We have two main categories of categorical data. This is the dichotomous data or binary data. This is the kind of data where it has only two possible options, where it's yes or no, true or false, positive or negative, or think about as well like female or female. So this is the kind of data we can obtain. The other type of categorical data is called ordinal, and this is the kind of data that we can group things. For instance, a fruit can be a tropical fruit or from a temperate country or cold environment or arid. We can also think about uh, ordinal data like happy, very happy, sad, very sad, or the Likert scale information we often get. So how we work with this categorical data? Well, to summarize this data, we use counts, percentage, and ratios. And for this, we can use bar or dots charts or use tables for counts, percentages, and ratios. Let's see how is this done. This is a data set that contains information about the presence of anti-resistant genes in different sorts of samples. The samples are, for instance, broilers, um, unimported milk, or local meat. So this variable can be considered as a ordinal data. The second type of data we get is the ESBL phenotype and this AMPC phenotype. These categories are recorded as dichotomous variables, where the outcomes is 0 or 1. 0 means false or negative, whereas 1 means that is positive. So what can we do with this information? The first thing we can do is to count, so to take the frequencies. How many broilers were negative to these both types of antimicrobial resistant genes, and we got 700, over 700. And so for the local meat, we got 200 and so on. And let's take an example here where we had broilers where they have both type of antimicrobial resistant genes, and there was only one case. And we got 12 cases when AMPC phenotype was present for foreign meat and negative for the ESBL phenotype. So this is the kind of frequencies you can start to make when you get categorical and dichotomous data. The bar plot is a very important way to summarize categorical data. And in this case, we have this dichotomous data, SVL phenotype, and we count here how many negatives or zeros we got, and how many ones or positive cases we got in our dataset. There are some variations of the bar charts, which are called the stacked and cluster bar charts. And here I have an example of this, what is called the stack bar, where the information is stacked here by these three type of samples. When it's negative and when it's positive is here. So it gives already information about that foreign meat is perhaps a way to investigate more, because is where we are getting more antimicrobial resistant genes. And the same information here when we got this cluster bar where the information, the bars are Dutch. Finally, it's also important, for instance, to obtain percentages. We get percentages, for instance, for the type of samples we got. So we got 66% more information from broilers and less from the different type of meat origin. And we also got here the information about the percentage of SBL positives and AMPC positives. A very useful way to summarize data is by two-way table, where we got as well here the negative and positive of SBL, and we count how many times we got this observation as negative for broilers, and the times we got it for broilers but positive, and for the rest of the samples. So we learned today about how to summarize our data. We can do this in numeric data with graphs, which are called the whisper and box plots, and the histograms and line graphs. We got the opportunity to do a range of statistics and summary numbers. Summarizing categorical data, we use counts and percentages, and we can graph as well with bar charts and two-way tables. So this is it.